Hello and welcome to Studios Projects. Today I'm going to talk about something very near and dear to both my heart and my wallet, which is the battery that goes to my e-bike. This battery is exceptionally safe. It has 2 fallback systems and technically a third. So to start off with, we have an active balancer. Now, I had this on because the flashing light goes on a lot. An active balancer goes and makes sure that the voltages of the individual cell packs are the same. Now, it depends on how much, like you can have it set to 1,000th of a volt off or 100th of a volt off. Personally, I like to set it to 100th because it allows for some wiggle room. Now, this is a 14S balancer because this is a 14S 4P battery and it uses 21700 cells and it is 1 kilowatt hour or 1008 watt hours. The 8 just gets thrown away. And yeah, so this is for 14 cells. So now this works perfectly. This is also a Bluetooth module. So in other words, I can use an app, which I'll show right here-ish, that actually shows the cell voltages whenever I want. I just have to connect to the app, which is very helpful. And since this thing does not turn off, unless I make it turn off, it will always be broadcasting the voltages. So I can always go and check to see if I need to charge them or not. So this was, I think, about $50-ish. It's a very good company. I'm fairly sure it's the same one that Daly makes, D-A-L-Y. Daly, I don't really like a huge amount just because a lot of their stuff breaks and their customer support is garbage. But this thing pretty much makes it so that when I'm discharging or charging, the cells never get too far out of whack, which since this is technically only a year old and the cells are acting a little bit finicky just because the fact that, well, I haven't used it in 2 or 3 months. This is really useful because it keeps everything within range safely without having to do a whole lot of intervention. You just got to solder a lot more wires, which this little thing right here is the wires. It uses a JST PHR 15 connector, which just means 14 and 1. And yeah, now this, I will also just start and say, this thing right here, this is so I can control the LEDs on my bike. This does not have any anything related to the battery. I just put it on the battery. That's it. I mean, you could literally see it's just, it's literally just an LED thing. So now we get to the back. Now this does not look as nice, but here is where the BMS is located. It's a 14S 30 amp discharge BMS, so it's able to do quite a bit. I personally don't discharge from the BMS just because with my bike it can do well over a few hundred amps. Like I have a 1,000 watt motor and I have a power supply, or I have a motor controller that can easily do well over 1,000 amps if you push it. Well, no, not 1,000 amps, 1,000 watts. So this BMS is very important because it allows me to charge the cells without having to worry that they're going to charge out of whack. Like if you just charge it by plugging it into the battery itself, you could have cells that go up to 4.5 volts, which they shouldn't. They should stop at 4.25 for safety. And you could have other cells that are 3.5 volts, which that actually almost happened to me, but thankfully I had both the active balancer and the BMS. The only problem with this BMS is that it charges up to 4.1 volts, which it's not the greatest, but you still do lose out on a volt and a little bit more. But honestly, being able to confidently charge this thing with either a dumb charger or a smart charger, dumb versus smart being where it just constantly puts out a certain voltage until it drops a little bit, and then the other one, a smart one showing like temperature, has a fan built in and all this other stuff. The dumb chargers can usually be about $30. The smart chargers, which I'll put a photo of the one that I have here, can be sometimes $60 to $70, maybe $80. The one that I have is $80, which is not cheap, but you're paying for something that's never gonna overheat because it has a fan built in and it's super safe and it's gone through a lot of quality control checks. So those are the 2 active and passive systems on here that keep this thing safe. And now for the thing itself. Now I'll find photos of the cells just because I don't want to take this apart because I made it so that it doesn't get taken apart. But inside here are 21700 Samsung cells. They are very high quality. They're about, at this point, I think $7.50 a pop per cell. So this is not a cheap battery to say the least, but this is rated for 100 amps total discharge. It has 4 strips of nickel plating on each of the serial connections. So pretty much that means that I can discharge at most, nominal voltage is about 50.7 volts. So at nominal voltage, I can do, if it's rated for 100 amps, I could do 5,000 amps, technically. Technically. Not realistically, because at such a low voltage, I'm going to have to draw a lot more, or it wouldn't work as well, but this thing is rated for constant usage at anything below 100 amps, which is amazing. And technically, I have done 100 amps on this in testing. Granted, it drained the batteries instantly, which makes sense. But this thing is just, it's beefy, it's made to work on anything, and since these cell wires right here, you can just take and pull out, I'm able to individually test any of the cells and individually charge them if necessary. Like if one cell gets out of whack and I need to get home, I can just use a 4.2 volt charger and just charge off of it. So, all good. So that's the electrical systems. Now, this also is very good, or it's very safe, because of physical systems, just systems that I designed it so it works really well. So to start off with, this plate right here, it's a fairly thick plate. This is what keeps the actual cells in the battery, or in the housing. This is also made out of PLA, plastic, so it's going to take a long time for it to decompose, and it's also going to be fairly strong. It has the rigidity of ABS, but also it's a little bit bendy like TPU. So, I mean, granted, it's just PLA, but it's strong, and it's not going to just shatter on impact. So, we have that to start off with, and it goes the entire length of the battery, and has 4 screws to hold it in. So, it would take a lot for both screws to fall out, or for all the screws to fall out, and for this thing to fall apart. We also have, the housing is made out of PLA. I used a 0.8 millimeter nozzle to go through this pretty quickly, and the way how it's printed is, it's printed like this. Obviously it's 2 different prints, but it's printed like this so that it's not going to shear out from the middle. It had to shear out like this, and when you have the battery sitting like this, if it shears out, it's not going to be able to, like, the entire thing would have to crack open like an egg, which is not physically possible because of the fact that my bike has 2 security rails to also reinforce the frame. So that's another thing. I also, in the cracks that I took, because I printed it, as you can see here, with pretty much a zigzag motion in it, it's not going to be able to fall apart in, yeah, it's not going to be able to fall apart as easily. It's not just going to slide clean off. Like, it actually has to bend apart. I'd also, if you look at the crack that's there, there's glue in there. Now, there's a mixture of super glue and crazy glue, super glue and hot glue. So the crazy glue, or the super glue, is meant to actually hold the thing together, and the hot glue is just to keep it insulated. So realistically, if I took this and I put it through a rainstorm, which I never would advise you do if you're going with a DIY battery, unless it's very secured. This is outside of its normal container. Like, this gets on my bike, and then this thing gets covered. But this thing is very impertinent. It won't get affected by water. The only way that it could get affected by water is if water gets in here, but this place is fully closed off once it goes on my bike. It's fully shielded and it's fully enclosed. And I also replace the tape every so often. So, yeah, I mean, I just wanted to make this video just to show off this battery and just to put it on the record that I built one, because my school just released a rule pretty much saying as long as you're not an idiot with your electric bikes, you can have it on campus, which that was something that I was afraid of not being able to do. And yeah, so I'm very happy that I get to use my electric bike on campus, and Walmart Special will get to see another day. So thank you so much for watching. If you have any questions about like what type of stuff you should buy, put it in the comments, and yeah, have fun. I'll see you next Sunday, 8 a.m., the usual time. Bye.